Welcome to your next lesson. So we are already on lesson number 6. There's only a few more left before we're ready for STAR. This lesson is labeled Scale Factor and Similar Figures. Make sure you title the top of your journal entry. I've already cut out my foldable and then glued it into the journal, so you'll need to take some time, maybe pause the video and do the same. Be careful when you're cutting these. They don't seem to match up just right. So just really be careful when you cut these out. So the first section is on similar figures. And that's gonna be where sides are, let's actually open it up. So they have the same shape. So the same shape, but not necessarily the same size. And they have the same angles. So their angles, they call it congruent. Angle measure. So the same shape but not necessarily the same size means that they are proportional. So they're gonna shrink or grow, get bigger or smaller all at the same time. Like every side is gonna grow or shrink at the same rate. And then the same angle measure is also saying that their angles are congruent. That's the geometry word, just to say that instead of like equal numbers, we're talking about equal space, like congruent angles, meaning same size angles. We are going to be using proportions to solve these. All right, so for our first example, we have a parallelogram ABC that is similar to parallelogram EFGH. We're going to find the value of x. So we want to find this right here. So to set up a proportion, we need to make the same comparison twice. There's actually about 4 different ways that you could set this up. So I could say the first comparison that AD, or x, is comparable to EH, 18. So if I make that comparison though, I need to then set up another exact or equal ratio. So I'm now going to maybe say that AB is 16. So I'm starting with this parallelogram, is going to be proportional to side EF. So this would work for making a proportion. So I could do that way. Or I could make it in a proportion just doing the same comparison, one rectangle to the next rectangle, meaning I could go x, so this side, compared to this side on the small rectangle, is equal to 18, or this side, to 24. Go ahead and use a calculator to solve for x, and notice that both proportions are going to give you the exact same answer. You could even do another proportion where you have 24 to 16 equals 18 to x, or you could do 16 to 24 equals x to 18. So there's 4 different ways you could set this up to make that equal comparison twice, to show that the sides are proportional, that they're growing or shrinking at the same rate. Please solve this before you move on to indirect measurement. So we should know how to solve proportions from lesson 4. Indirect measurement. So it is a form of using a proportion to find a missing length or distance in similar figures. So for example, here we have that famous tree and shadow problem. I feel like that happens a lot, that problem. So a tree casts a shadow of 125 feet. So here's our tree. Here's our tree casting a shadow of 125 feet. On the same day, a 4-foot, 10-inch woman casts a shadow of 5.5 feet. So here is our woman. Her shadow is 5.5. Her height is 4 feet 10 inches. So that would be not all in feet. We would need to convert that 10 inches into feet to make that an appropriate comparison. We don't want to have mixed units. So there's 12 inches in a foot. So I could do 10 inches out of 12. And I could then simplify. And 12 goes into 100. Say, what, 8 times? 16, carry the 1, 8, 9, so 96. The remainder of 4. So let's just say she's 4.8. Now we could set up a proportion and figure out how tall the tree is. So we're trying to figure out how tall is this tree. So we have x to 125, and then we found that she's about 4.8 feet compared to 5.5 feet. Cross multiply and divide to solve for x. So go ahead and use a calculator for this one, but you can cross multiply and divide to solve for x. The last one is scale. So doing a scale drawing. So a scale drawing is an enlarged or shrunk, or let's say reduced. So either the enlarged, like getting bigger, or reduced, getting smaller, drawing of an object that is proportional to the actual object. The scale is the we'll come back to that. I don't remember what goes in these blanks, but we'll take a look. So for in this case, we have a scale given to us. We are given that the scale for 2 inches on the model is 5 feet on the actual. So we're gonna say that the scale is 2 inches to 5 feet. So that will tell us for any dimension on this house, I could figure out how big either the model is or how big the actual is. In this case though, they gave us the height of the model house. So I'd put that in the small or the inches category, model category. I want to find how tall it is actually in feet. So go ahead and cross multiply and divide to figure out how tall the actual house would be. If for every 2 inches on this little tiny house, there is 5 feet in the actual house. And then the scale is the, show that the light in. I'm gonna tell you, we'll figure this part out. I'll probably put this on the board because I'm blanking on what goes into this. But the scale is really just talking about your model, so here's my model, to actual. Like at what rate is it increasing or decreasing to go from model to actual? Or 2 inches to 5 feet. So every 2 inches here, there's 5 feet here. All right, enjoy. You guys have practice. Woo, practice. And then you have your quiz on scale factor and scale drawings. All right, nice job, you guys.